right, now we're looking at making the graph of y equals tan 2x plus 1. So this time our 2 is a b value. So we've got b is equal to 2. Let's pick a different color here. This implies now that our period is going to be equal to pi divided by 2. So normal period for tan is pi, and then dividing by my b value makes my period pi over 2. I know that I normally have my asymptotes are normally at pi over 4, sorry, not pi over 4, pi over 2, 3 pi over 2, etc. Now they're going to become pi over 4, 3 pi over 4, because these are affected by my horizontal stretch. So instead of being at pi over 2, now I'm going to have an asymptote at pi over 4. We can test that by thinking that y of tan 2 times pi over 4 plus 1, well, this becomes pi over 2. Tan of pi over 2 is undefined. So now I have my asymptotes at pi over 4, 3 pi over 4, and this goes along with shrinking my period. If I think about putting my asymptotes in at, so pi over 4, 2, 3, this would now be pi. So pi over 4, negative pi over 4, 3 pi over 4. So I can see now that my period has shrunk down to be pi over 2. All right, my center line is shifted up. So now I've got points, we could call this 1. So I'm in the center, up now at 1. If I go half the distance here, that's where I would go up 1, down 1. So we could test this as well. This would be pi over 8. Sorry, negative pi over 8. So y equals tan 2 times negative pi over 8 plus 1. Well, that's going to give me tan of negative pi over 4 plus 1. Tan of negative pi over 4 is negative 1 plus 1 is 0. So this point checks out. And so I see that my period has shrunk for my tan graph. I have narrower lines. And I'm plotting again 3 points to help me see my curves. And I'm going to plot 3 curves to show that this graph continues going.